In this video, we look at some more examples from section 4.7 on L'Hopital's rule. Right, and at this point, we have learned that L'Hopital's rule tells us about how to compute a limit as x goes to a of f of x divided by g of x. In the case where the limit, when you first initially look at it, comes out to be 0 over 0, infinity over infinity. Okay, we looked at these two cases. These are both examples of indeterminate forms, and we've decided that the answer depends, for the limit, depends on the rate of the function f and g, how the rate of the functions change, right? Okay. There are other indeterminate forms. Indeterminate forms. And they both come from manipulations of, like, say, 0 over 0, for example. 0 over 0 is the same thing as 0 times 1 divided by 0. But 1 over 0, we decided, is like infinity. 1 over a really small number is a big number. So 0 times infinity is another indeterminate form. Okay? We've decided that two numbers, infinity minus infinity, that determines is something indeterminate, because you really have to think about what would two really infinitely large things be if you subtracted them. And it's not equal to 0 all the time, because the answer depends on whether or not the function f minus g, how the functions change. Okay? And so here's an example, what I will call an example on the medium difficulty scale. Right? And that would be like problem number, say, 27 that's shown there. Or let's look at 28 since it's even. The limit as t goes to 0 from the right of 1 over t minus 1 over e to the t minus 1. Okay? Now, we're seeing that as t gets close to 0 from the right, 1 over t, which looks like this as a graph. Here's a graph of 1 over t. As you get close to 0 from the right, we're getting bigger and bigger numbers. Okay, so that would be like infinity. And as t goes to 0, e to the 0, the exponential function, e to the t, as t gets closer and closer to 0 from the right, our function e to the t is getting closer and closer to 1. So 1 over 1 minus 1 is 1 over 0, which is infinity. So the question is this limit going to equal 0, or is it going to be equal to something else? And the answer is that it depends, because this is an infinity minus infinity indeterminate form. And the way to approach this problem is the limit as t goes to 0 from the right. Let's take a look at this infinity minus infinity problem if we get a common denominator. Okay, so we'll get e to the t minus 1 minus t. There's our common denominator, which leads us our infinity minus infinity limit, if we do a little bit of algebra, turns into e to the t minus 1 over t times e to the t minus 1, which is another way of saying we now have a 0 over 0 indeterminate form. Okay? So the infinity minus infinity, once you did a little bit of algebra, it got converted into a 0 over 0 form, which is indeterminate, which means that the answer depends on the rate of change of e to the t minus t and the rate of change of t times e to the t. So L'Hopital's rule says that if we have the limit of a function f divided by a function g, we can instead compute the limit as t goes to 0 from the right of the derivative of those functions. Okay. And the derivative of those functions is e to the t minus 1. There's the derivative of the top function, and the derivative of the bottom requires a product rule. First times the derivative of the second plus the second times the derivative of the first. Okay. And now we look at what happens. What happens as t goes to 0? You get 0 divided by. Now you see if this limit is any better to compute. You get 0 on the top as t goes to 0, and on the bottom you get also 0 plus 0 again, so you get 0 in the denominator. So you get 0 over 0 form. That doesn't mean you can't keep going with L'Hopital's rule. The limit as t goes to 0 from the right. The derivative of the top is e to the t. The derivative of the bottom is first times the derivative of the second plus the second times the derivative of the first plus the derivative of e to the t minus 1 is e to the t. And now as t goes to 0, right, of the top you get e to the 0, which is 1. The denominator goes to 0 times e to the 0, e to the 0 times 1 plus e to the 0, in which case you get 1 divided by, this part is 0, e to the 0 is 1 plus 1, which is a half. So if you were to guess here that infinity minus infinity was 0, you would have been incorrect because it depends on the growth rate of the functions 1 over t and 1 over e to the t minus 1. And evidently their growth rates show that they are, one of them is not growing fast enough to, they're not growing at the same rate, or else they would cancel, give you 0. You just get 1/2 for this limit. Okay, so there's another indeterminate form. We've looked at 0 over 0, infinity over infinity, infinity minus infinity, and then there are some 0 over infinity examples, which I think is probably on the easy end also, and infinity minus infinity is on the medium difficulty scale. Okay? Alright, so ends this video. In the next example, we'll look at a harder example.